Okay, this is the screencast for section 1.1, modeling and equation solving. First, we're going to look at some numerical models. A mathematical model in general is using some sort of math, and we're going to learn 3 different ways in this section, but using some sort of math to approximate situations and to study and predict their behavior. A numerical model is probably the most basic one that you have seen. Probably the easiest ones to deal with. It is straightforward numbers. It is data that shows you how one variable is related to another. So we're going to look at this chart down here. This table tells us about the minimum wage. A lot of you have your first job. Who knows, maybe you're in your third job. I don't know. But minimum wage has increased throughout the years, sometimes staying the same, just depending, at different rates. And the purchasing power in dollars has also changed. So this is in 1996 dollars. So for example, in 1955, minimum wage was 75 cents, which was a purchasing power of $4.39 in 1996 dollars. So it'd be the equivalent of, if this were 1996, making $4.39 an hour. Or 2005, the minimum wage was $5.15, which purchasing power is $4.15 in 1996 dollars. Our current minimum wage is $8.25 an hour. I'm not really sure of the purchasing price or the purchasing power of that. It'd be interesting if one of you guys could figure out what that is. So anyway, example 1 asks us to track the minimum wage. The numbers in table 1.1 show the growth of the minimum hourly wage from 1955 to 2005. The table also shows the minimum hourly wage adjusted to the purchasing power of 1996 dollars. By the way, my first job when I was 15 years old in 1995, minimum wage was $4.25. There it is. I was making $4.95. Woohoo! Look at me. Anyway, answer the following questions using only the data in the table. In what 5-year period did the actual minimum hourly wage increase the most? Okay, so the minimum hourly wage, we got 25 cents here, 25 cents here, 35 cents here. I mean, we got 50 cents here, so that's good. That's a whole dollar. So at this point, we're trying to beat a dollar. Didn't increase a dollar, didn't increase a dollar. Here, we moved up to a different dollar, but not a whole dollar. Here, we didn't move up a dollar. There, we didn't move up a dollar. That was that dollar jump. So there was a dollar increase from 75 to 80. I bet that was huge. Made the news. In what year did a worker earning the minimum hourly wage enjoy the greatest purchasing power? So looking at my purchasing power over here, the greatest purchasing power, let's see, was right there in 1970. It was the equivalent of $6.47 1996 dollars. So in 1970. A worker on minimum wage in 1980 was earning nearly twice as much as a worker on minimum wage in 1970. Let's see here. 1980, $3.10, 1970, $1.60. Twice as much of $1.60 as $3.20. So close. Fine. And yet there was great pressure to raise the minimum wage again. So it almost doubled in 10 years, but they wanted to raise the minimum wage again. So to me, that implies I need to look at the other column, because if we doubled the minimum wage, it's not about how much the minimum wage went up. It's probably about what happened to the purchasing power. And yep, sure enough, there you go. From 1975 to 1980, the purchasing power actually dropped and kept dropping. Look at that. Kept dropping. So we needed to raise minimum wage to catch up with the fact that the dollar was losing its value. So let's see. The question was, why was there pressure to raise the minimum wage again? Because the purchasing power was dropping. The now try problem that goes with example 1 is number 11 from your exercises. The directions say refer to the data in table 1.6, which is right over here, below. off to the side, showing the percentage of the female and male populations in the United States employed in the civilian workforce in selected years from 1954 to 2004. So in my head, I'm thinking selected years sounds a little weird. So I'm going to look over here. I do actually see 5-year intervals for each, quote, selected year. The reason I wanted to check that is if we only changed by 1 year sometimes and 10 years other times, that could be a more dramatic or less dramatic change depending on the situation we're dealing with. Because if we moved a lot, but it was over a span of 10 years, it may seem more dramatic than it actually is. Whereas if we move a lot over 1 year, that makes it a bigger change, more impact. So over here I can see we are making 5-year intervals, so I don't have to worry about the difference in time. So going back to the question, according to the numerical model, what has been the trend in females joining the workforce since 1954? Well, we're looking at the percentage of females that have joined the workforce. So in 1954, 32.3% of females were in the workforce. That number, or that percentage, excuse me, has been increasing, I think, all the way through here. Oh, except we got a small little decrease from 1999 to 2004. So I am going to write down my answer. Oh look, there it is. Don't you wish you could do that? The percent of females joining the workforce has increased in general from 1954 to 1999, with a short decrease from 1999 to 2004, or a small decrease. B, in what 5-year interval, so what single change that has been recorded, did the percentage of women who were employed change the most? So I'm looking for the most dramatic change in each of these 5-year intervals that are measured. Let's see, just off the top of my head, about 3% here. 1, no. This is a little over 4. So far that's the biggest change. No. Ooh, that's a good one. 42.8 to 47.7. That actually might be the biggest one so far. Nope, that's less than 3. Go on, less than 2. These are tiny. So the biggest change in the percent of women employed took place between 1974 and 1979, which so happened to be an increase of 4.9%.